Hello and welcome. Higher Maths Vectors, Chapter 6, Exercise 6E, question number 10. Quite a tricky question. A question that is very similar to an old exam question that was near the end of paper 2. So in the trapezium PQRS, the lengths of the sides PQ and PS are 5 and 4 units respectively. So the magnitude of A is 5, the magnitude of B is 4. The vectors A, B, and C are shown as on the diagram. Evaluate A dot B plus C and C dot A minus B. So A dot B plus C, hopefully this one's reasonably straightforward, guys. So we just expand like we have done in the previous questions. If you've gotten this far through the exercise, I'm sure this will be fine. So A dot B plus A dot C. So A dot B is the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle in between them. So that'll be 5 multiplied by 4 multiplied by the cosine of 30. A dot C, the magnitude of A multiplied by the magnitude of C multiplied by the cosine of the angle in between. So A is perpendicular to C. So they're at an angle of 90 degrees. Remember, we can move either vector A or vector C about, but the direction of those vectors cannot change, so that they are both pointing away. So I would move C, vector C, I'd move it along to the left and down so that it's coming out of corner P, and then would find that the angles are perpendicular to each other. So as they're perpendicular, A dot C will be 0, and that is because the cosine of 90 degrees is 0. So at the moment, we have not covered exact values. We're doing that first thing when we get back to school in August. So we could just evaluate this on the calculator, but the cosine of 30 is root 3 over 2, so it's 20 multiplied by root 3 over 2, which is 10 root 3, because 20 divided by 2 is 10, multiplied by root 3 is 10 root 3. Now the tricky part of the question, C dot A minus B is C dot A minus C dot B. Remember from part 1, A is perpendicular to C, so C dot A will be 0. So we've already kind of worked that out up here, because A dot C and C dot A are the same thing. So all we're evaluating is negative C dot B. So again, the vectors must point away. Oh, computer's being a bit laggy. Oh, gone too far again. Sorry about this, guys. Come on. Oh, dear me. Hooray. Right, so negative C dot B, so they must point away from each other. So I am moving vector C down, so that's coming out of P. So this, on the original diagram, this corner here will be point P. So there's an angle of 120 degrees between them. So I've got the negative of the magnitude of C multiplied by the magnitude of B multiplied by the cosine of angle 120 degrees. So that seems easy enough. However, there is a problem. We do not know the magnitude of C, although we do know that this angle, again, this would be corner P. This angle is 30, this is B. We can move C along to the left so that it goes to S on the original diagram. And then we're going to have to use sine 30 as the opposite side over the hypotenuse, which should be the magnitude of C over the magnitude of B. So I know the magnitude of B is 4, so I'd have 4 sine 30 equals C. So 4 times a half is 2, so the magnitude of C will be 2. Okay, so that for me, certainly, maybe not for you guys, you might see it a different way, but for me, I think that's the most difficult part of the question. And the reason why it's the most difficult part is it's slightly, I wouldn't call it unusual. It's just basically a different structure to the rest of the questions, and we just need to spot that we can use right-angled trigonometry to find out the magnitude there. So once you've done this and a couple of past paper questions, that'll probably become quite straightforward for you. So we've got magnitude of C is 2, magnitude of B is 4, so negative 2 multiplied by 4 multiplied by cosine of 120 degrees, which is the same as the negative cosine of 60. Again, we've not done exact values yet, so we'll do that first thing after the holidays. So just evaluate on the calculator, and we get 4.